Hello friends, welcome to my next video tutorial of steel warehouse design with build-up section using Staad Pro version V8i. In this particular video tutorial, I am going to show you a total three-dimensional analysis and design of this warehouse as per my this drawing. This is my roof layout plan. This is my main adapter, main portal frame, and this is my gable portal frame. So I am going to show you using Staad Pro and also using build-up section step by step how to complete this project. So to start this project, open Staad Pro program, then click here from this project tags, new project, check this space, next, yes, then click here finish. From this right side, close this windows, and as per my this drawing, I have a total building length approximately 42 meter and also width of 30 meter, and base spacing is 6 meter, and also my gable column is at the rate of 6 meter center to center. So I am just drawing this any column point first. From here write a 0 here in this cell, then just click it below. Now you can see a black dot has been drawn here, which is a node. From this left side, select this node cursor and select this node. From your keyboard, hold down Ctrl key, then press C again, and keep holding your Ctrl key, press V. So this is a simple copy and paste. Now it is asking to show here the distance, so I want to copy this along X direction, and I have a 30 meter span, so 30. Okay, take this add beams, click this node, then click this node. Now you can see, press ESC button to exit from the command. Now you can double click on this, you can see a 30 meter length beam has been drawn here. And as per my drawing, I have a 6 meter of clear height of my frame. Copy this, select this one, click here this icon, transitional repeat, select along Y direction, this is 6 meter, click, check this link steps, then OK, done. Now delete this lower level beam, select, then press delete from the keyboard. OK, select this one, and from here insert node, add midpoint. OK, select this right side portion, again press delete. OK, yes. Now I have, this is 115 meter, so I have my rafter slope is 1:10. So if 1:10, I have to move this node to 1.5 meter. Right click, then move, go along Y 1.5 meter. OK, yes. And now if you see, I am drawing my this frame first. I have first segment of this rafter is 6 meter. Select, take this beam cursor, select this rafter, go to here insert node, right here 6 meter, add new point. OK, select again, I have another 6 meter of rafter, then desktop will be tapered, then select that one, insert node 6, add new point. OK, so my this part will be tapered as per my this drawing. Now select everything from here, click here generate mirror, click on this icon, then select this node. I want to mirror this around this node, and now it is asking, you can see here a image how to mirror this. So I want to mirror this total portion to this right side, so I have to select plan, and I have plan is along YZ, so YZ is by default selected, then click OK. Now you can see it has been drawn. Now go to here general, then support. From here create pin support, add a pin type of support. You might have fixed or any other type of support. Then select this support, take this node cursor, select this node and this node, assign, yes. OK, done. So I have just created a two-dimensional model of my main frame. I am going to define size first so that it is easier to edit next time. So go to here general first, then geometry again general, and now you can see, if you want to use hot roll section, you have to go to here this section database, and from here you can see lots of code list and lots of available hot roll size. Here you can pick up any size from here, but I am not using this. I want to use build up section to do my complete project here. To define build up section, go to here define, then tapered one, and I have my this column. You can see here, this is the tapered column. First I am defining my this main column. I have the depth at the start node is say 0.35, which is 3500 mm. Thickness of the web say 0.0108 is 8 mm. Then depth of the section at end node, this is say 0.70, which is 700. Then width of the top flange say 0.25, which is 250 mm. Then thickness of the top flange say 0.010, which is 10 mm. And the rest of two value, which is with the bottom place and thickness of bottom place, you can just put here 0. So if you put 0, it will count as 0.25 and 0.01, which is 250 mm and 10 mm. Now click add. So this is my main column. Then I have my this tapered adapter. So I will change this value a little bit. Say I have this is 300 here, this is 8, maybe this is 6, and this is maybe 8. Then I can also change this to 200 or to keep it to 50. Click here add. Then also there is important thing, the width of your this tapered column here should be equal to the width of this rafter here. So that's why I have not changed this 700 to any other value. So and next I have this similar with rafter. I am going to do, I have here 300, so I must have the width 300. So this is 0.30268. I can change this to, so this is 250. Okay, then add. And the next I have this tapered one, and this is 0.3, say this is 0.55, and this is 6 and 8 mm 250. Okay, add, then close. Now select this tapered one, select this two column, assign to selected beams, assign yes. Select next one, I have this for these two rafters, assign. Select this one, I have for this middle rafters, assign. Select this one, I have for this top rafters, assign yes. Now go to here, this icon symbol on labels, structures, full sections, apply. Okay, now check if your direction is okay. The direction is not okay for my this one, so here double click, change this to 0.7 and this one 0.3, change, close. Now you can see the shape is okay now. And now as you see in my drawing, I have 1 2 3 4 5 6 7 bay. So select everything this way, then go to here this transitional repeat. I have to go along Z, spacing is 6 meter, total 7. Then click here OK, and go to here this top view, and now check 1 2 3 4 5 6 7 bay. Okay, go to here this isometric view. Now you can check you have drawn your main frame, but I have here and here my gable frame, and I have more column here, so I have to change that. Take here this add beams, draw a beam here, select this one, and I have more 1 2 3 4 column. Select this one, insert node here 4, add endpoint, then OK. Hold down the shift key, then press K to display the node. Now take node cursor, select all these 4 nodes, then go to here again transitional repeat, and I want to go along Y, say 8 meter. Just go to a little bit higher than the total height, then link steps. OK. Now click here beam cursor, select this one and also this rafter, this one, this rafter, this one, this rafter, this one. Okay, this rafters. Go to here geometry, intersect selected member, intersect. OK. OK. Now just select the upper portion of this column, press delete from the keyboard. OK, yes. Now select this lower portion of the beam, delete. OK. And now I have to define column for this or this 4, and before that I can go to here support, select support and select for all this 4 column, then assign yes. Now go to here general, then geometry, then general again, and go to here define tapered one, say I have 0.3, 6 mm, 0.3 here, 0.20, here is 0.008, say. Add, close, select this one and select all these 4 columns, assign yes. Now go to here this icon again, symbols and labels, structure, full section, apply, OK. Now you can see the orientation of this column is same as my main column, but it will be different because I have this column oriented in the other direction. Here you can see the column orientation is changed. So to change the orientation of this column, you have to go to here beta angle, create beta angle 90, OK. Select this beta angle and select these columns, assign yes. Now you can see this column has been rotated. This way you can rotate a column, OK. If you need to rotate any column orientation, you can do this way. Now I have to draw these 4 columns similar way here, and before that I have this rafter is not tapered. I have this is similar size of rafter. So if I go to here general again, and I can define another size for this one, go to here define, then tapered, I can define a 350, 06, 350, then 158, add, close, and select all these rafters. Now assign to selected beams, assign yes. Okay, now I have to copy all the arrangement from here to here. So if I want to use mirror command, I can do that. Select. So to use mirror command, you have to make a temporary beam here. Click add beam, draw this point to this point, select this one, add midpoint, OK. So I have to mirror this along this nodes. So select this beam, select all these columns, click this generate mirror, click this icon, click this node, then I have to go along y-x plane, so I have to select y-x, OK. Now you can see it has been shifted. And now if you check from going to here, symbol and labels, structures, full sections, apply, OK. Now you can see the model creation is done. I have to delete this temporary beam, just select and delete, OK. And I have another thing to do. Go to here this view from Z, click here node cursor, select node this way, and also this node, also this node. Go to here display whole structure. Now geometry, connect beam along Z, yes. So this is my stud member, I'm just drawing here. So I have to define a size for my stud member. You may have any other size. I'm just defining a I section here, going to here define tapered one. I have this is say 100, this is 0.04, 100, this is a 0.075, this is 0.003, 004. So 100 by 75 and 4 mm by 3 mm. This should be 4 and this is 5 mm. So this size I'm just defining for my stud members. Click here add, close, select this one and go to here select by missing attribute, missing properties, assign yes. Okay, done. So my model creation and assigning of various member is done. And now I have to release for moment if I have no moment in any connection. For example, here I have this is pin type of connection, this. So this column in the gable and connection between this column and this rafter should be hinge. So I have to go to here, and here I have defined this one for my rafter. I have to assign this for my this rafter. Select all this rafter and assign yes. Okay. Now I have to just release moment for my stud member first, because this stud member will not take any moment with this connection. This is a simply pin type of connection. Double click on this stud member, click here this change release at start, check this partial moment release, check this MPZ, this is 0.99, so 99% moment will be released there. Add, select the next one, change release at end, then partial moment release MPZ, this is 0.992, add, close. Now you can see, if you just zoom this, you can see a circle has been drawn at each end of this Staad beam. So similar way, go to here, general, then specs, and select this one, and now select all the Staad member by going to here, select by specifications, member name, the tapered 8 is the size, then close. And when this is selected, make sure assign to selected beams, assign yes, select the next one, assign yes. Now you can see all the Staad member has moment release. Now double click on this gable column, click here at the change releases at end, from here partial moment release, click here MP, this is a 95, so 95, or you can use 99% moment release. Usually I use 95%, then add, close. Now you can see a blue circle has been showing here. So same way, when this is selected here, select all other columns which are in the gable and assign yes. Okay, so my model creation and releasing of moment is done. Now I have to draw for my bracing. So to draw bracing, I have bracing at 1 bay interval. So take this at beam, I have bracing here, draw cross bracing here, then also bracing here, draw cross bracing here, also bracing here in this bay. Similar way, draw bracing at the other side. Okay, and now I have also roof bracing. So to draw roof bracing, I have to do something by going to here. I have a roof bracing point at almost 1.8 meter from this point. So if I go here, I have this node and I have to go almost 1.8 meter away to draw my bracing point. So if I select this one, this one, this one, all this middle rafter, then go to here, insert node, here say 1.8, add, okay. Similar way for this one, all of this same way, I have 1.8, okay. And now I can draw my bracing here by going to here, add beams, draw bracing, this point to this point, 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 this one, and this one, select. And similar way, I have to draw my bracing for my other base. Draw bracing in the same way, here, here. So now you can see I have completed drawing my bracing. Now I have to define a size for my bracing, and I am going to use here cable bracing. So to define bracing, click here general, geometry, then general again, then go to here section database. From here I want to use, go to Dutch, there here solid round, I have R20 or 19 R20 here, and I'm just using from Dutch. It is not a problem because I will design this customizedly. I have separate distance for this cable bracing, but I'm defining a rod here from this Dutch. You can use from anywhere or anywhere code, close. And now go to here geometry, go to here select by missing attribute, missing property. So all the bracing has been selected. Now assign, okay. And now you check here again, structure, full section, apply, okay. Now you can see your model is done. And there is also another thing, going to here specs and beam, you have, this is only tension for this cable, so the cable can take only tension, no other force can be taken by this one. So I have to define this as tension member, click at tension, add, select this one, and again go to here select by specification, property name, from here RD20, then close, assign, yes, okay. So my 3D model creation is almost complete, and now I have to go for the load assignation. I have not saved this model yet. Click here save as and save this model in your hard drive in any convenience place. And now I have to assign for load. To assign load, go to here from this left side, load and definition, then select this second one which is load cases details, click here add. From here first generate DL under the loading type none, add. Then I have LL which is live load, add. Next I have wheel load from two direction, one is left to right, another one is right to left. For this type of shade structure you have load two types, one is left to right, another one is right to left along the major axis. So I have WL to right, add. I have WR to L, so right to left, add, close. I don't have any other cases right now, so select this dead load first, then click here add. From here add self-weight factor -1, add, close, select this one. Then from here assign to view, check this one, then assign yes. Now self-weight is counted right now, and as per my wing load calculation you have to calculate your wing load as per your code requirement, and I have calculated my wing load as per my code requirement, and here is an overview on how the wing load is working here. And here I have roof dead load is 0.25 kN per meter square. Roof dead load is for the weight of the roofing material like purlin and sheetings. If you have tiles, then the load may be varied. And I have roof live load as per my code is 0.625 kN per meter square, and my base spacing is 6 meter. I have multiplied that value with my base spacing. I have dead load on the rafter is 1.5 kN per meter, and live load on rafter is 3.75 kN per meter. And for my end bay I have 0.75 kN per meter and 1.875 kN per meter. So go to here this model again, select this dead load, add. From here select member load -1.5 dead load, this is along GY, add. I have -0.75 for my end bay, add, close, select this live load, click here add. Member load I have -3.75 along GY, add. I have 1.875 for my end bay, add, close. Okay, now to assign load, go to here this top view. From here select this way only the frame, the main frame, right click, new view, okay. Go to this isometric view from here, and for my dead load select here 1.5 kN per meter, click here this view from Z, select all these rafters this way, then assign to selected beams, assign yes, then select this one 3.75 live load, assign yes, okay. Now go to this display hole structure, again top view, select this one and also this one, right click, new view, okay. Go to this view from Z and select this load 0.75 kN per meter dead load, and select all this rafter this way. Now assign to selected beams, assign yes, select this one 1.875 live load, assign yes, okay. Go to here this display hole structure. Now you can see the dead load and live load has been assigned on the rafter. Now I have wing load, so I have to define here my wing load as per my code requirement. I have calculated here my wing load here, and here is two combination 1 and 2. You have to try with these two combination. I am just showing you the procedure with this first one combination. And I have my load as per this. I have windward wall load is 6.74 kN per meter, as my base spacing is 6 meter. Then windward roof has 4.66, minus means it is just going outward from the roof along y axis. Then for my leeward roof is 3.79, this is the same. Windward leeward wall is 2.81, and I have for side wall 3.79. I have side wall is 6 meter, 3.79. So I have to assign this, and I have this load for my exterior bay, and this is my for interior bay. So I'm going to here my this model, save this one first, select this one WL to R, so this load will go from left side to the right side. So in this case I have this one is my windward wall, this one is my windward roof, this one is my leeward roof, this one is my leeward wall. So I'm defining load here. Select this one, add. First is for my windward wall member load. Here it will go along x-axis, which is the gx. This is positive. I have the value 6.74 for my main bay. Then I have 4.66, which is the local y. Add. Then 3.79, which is also local y. Add. Then I have for leeward wall 2.81, which is along gx. Add. Similar way I have the load for my outer side bay. So half of this load I have, this is 3.36, which is gx. Add. Then I have 2.32, which is local y. Add. Then I have 1.894, also local y. Add. Next is half of 2.81 is 1.4, which is gx. Then add. Close. So I have to define this same load for my wind right to left. So find the wind is going from right side to the left side. Select this one, add. For this case I have this column is my windward wall, this raptor is for my windward roof, this raptor is my leeward roof, and this column is my leeward wall. So I'm going to define the same load with opposite sign. Click here member load. I have the same load 6.74, which should be minus gx. Add. Next I have 4.66, which is local y. Add. I have 3.79, which is also local y. Then I have minus 2.81, which is gx. Add. And I have to define for the half load. Now I have minus 3.36 gx. Add. I have 2.32 a local y. Add. I have 1.894 local y. Add. Then I have minus 1.4, this is gx. Add. Close. Go to this top view again. Select this raptor, all the middle raptor. Right click, new view. Okay. And go to here, view from y. From here select this one. First time assigning load from left to right. Select this first load, then select these columns. Check assign to selected beams. Assign yes. Now next one for my this raptor, assign yes. Then next one for my this raptors, assign to selected beam, assign yes. Next one is for my leeward wall, assign yes. Okay, done. Similar way I have the load here, this one right to left, which is this one. Then assign to selected beam, assign yes. This one for my this side raptor, assign to selected beam, assign yes. Next one is for my this raptor, assign to selected beam, assign yes. I have made a mistake here. Double click on this and uncheck all this, double check mark, then change, close. Select this one and select all this raptor, assign yes. Now select this one, this will be for my this columns, leeward side, assign yes. Okay, now go to here, this display whole structure, and top view select this end raptor, this raptor, this raptor, then right click, new view. Okay, go to here, view from Z. Now similar way select this one. I am going from left to right first. This one assign to selected beam, assign yes. Next one, for my disruptors, assign to select beam, assign yes. This one is for my disruptors, assign to selected beam, assign yes. Next one is for my these columns, assign yes. And similar way I am assigning now W right to left. Select this load, select this column, assign to selected beam, assign yes. This one, assign all disruptors, assign to selected beam, assign yes. This one, select all disruptors, assign to selected beam, assign yes. And this one is for my this columns, assign to selected beam, assign yes. Now if you go here this 3D view, you can check the load is working here. And I have only one wind load else for my this gable column, and I have this is my gable column load, which is my side wall load. Here is 3.79. so I have to define this again. Go to here, wind WLTOR, to right, add member load, and I have this along Z, and this should be outside of the building. So if I define for this one, I have to define here two options. The first, I have positive 3.79, which is for my interior column here, and I have the same value with minus sign. Sorry, this should be GZ along, add, and I have this same value half of this 1.897, which is positive GZ, add. Then I have this one is in negative form, add. Now close and double click on this. This should be GZ. This is GZ. I have by mistake selected GY. Then change, close. Now select this one with right to left, add. From here member load, I have this is GZ. First is positive 3.79, add. Same value with negative sign, add. Now I have 1.897 is for exterior column, same value with minus, add, close. Now see how I assign this. So select this first one. I have this is positive, so positive will be this column. Select for these 4 columns, assign to selected beam, assign yes. Now see this load should act outward of the building. Then the next one I have for this, which is the opposite direction, same value. Okay, now select this positive one for my this exterior column, add yes. This one for my this exterior column, yes. Similar way assign this load, which is wind right to left. The positive should be these columns, assign yes. This one is for these 4 columns, assign yes. Next one is for my these 2 columns, assign yes. And the last one is for my these 2 columns, assign yes. So this is the procedure of assigning wind load as per my code, and in your code this should be the same, but the calculation procedure might be different. So you have to calculate your wind load as per your code requirement, then you have to apply the load manually. In this way I have just applied. So my load application is done. Now go to here, load and definition. Here you can see all the load definition is done. Now I have to go for load combination. Go to here, select this one, load case and load cases details, add. From here select define combination. The first combination will be dead load and live load, and this is factor 1. I am going to design this as per a AISC code. If you have any other code, you have to define as per your code requirement. So I have AISC code. I have this one, dead load plus live load. Select this one, the factor will be 1 here. Click this right arrow, then add. Now I have dead load plus wind load, which is WL to R. Select this one, this arrow, add. Again wind R to L. Select this one, this icon, add, close. So my load combination is also done. I have only 3 load combination here, and as per your code requirement you may have some more load combination, but I have only 3 for this type of structure. click here this display whole structure, and now my load combination and load assigning is done. Now I have to go for analysis. To do analysis, first click here commands, then analysis, perform analysis. Okay, go to here this icon, analyze tab, run analysis, or you can press Ctrl plus F5. I'm just clicking here save model. It will take some time depending on the size of your structure. When the analysis is done, click here, go to post processing mode, done. Okay, now you can see a green line with all the line, which is my deflection. Here it is showing deflection. By default this command is selected and the deflection is showing here as per my this combination 7. If I select combination 5, dead load and live load, now it is showing this one. And the important thing, before going to design, I have to go here this icon, Staad editor. From here search analysis, enter, and after the perform analysis write load list. I have load combination 5 to 7. If you have more, then you have to define here the range 5 to 7. You may have 5 to 10, 5 to 8, something else. So load list, why I am defining load list here? Because it will count the load combination 5 to 7 to design my structures. Otherwise it may show abnormal values. So make sure you have defined load list in your before completion of the design. So save, close. Okay, now I have to go for design, and after completion of design I will show you how to check various forces and how to finalize the member size. To start design, click here this design icon from this left side, and from here current code select AISC AST, then click here define parameter, and from here you have to define first your yield distance, and here FYLD, which is the yield distance of the steel, and I have the yield distance for my this type of member is 345.123 kilonewton per meter square. And I have a yield distance for my tension member, which is my cable bracing. I have, which is a high yield distance of 1200123 kilonewton per meter square. If you use any other material for bracing, you can change your value here, but I am defining this for my cable bracing, which has a yield distance of this amount. Then add, and now go to here below, which says UNT, unsupported length of the top flange. And for my rafter I have a purlin at 1.1 meter, so top unsupported length for rafter will be 1.1. add, and for my bottom UNB for rafter should be double the spacing of purlin, because I have east angle after one alternate purlin. So I have this is 2.2, which is UNB. add, and for my wall here I have purlin after 2.34 meters, so I have unsupported length, which is UNT is 2.34 for my all columns. Add, also UNB should be 2.34, then add, and now close. Now select this one FYLD. My FYLD will be for all except my bracing. So if I want to select all the member except bracing, I can go here, select by specification, properties name, from here select all, pressing the Ctrl. Due to breaking my model after defining the size, it has created lots of size here. So select all except this RD20, then close. Now you can see everything has been selected except this bracing. Now assign to selected beams, assign yes. Now this one for my bracing, same way, go to select by specification, properties name, go to all the way bottom, this one, close, assign yes, and select UNT 1.1. go to here top view, and from here select this way, select all the frames, right click, new view. Okay, go to here this view from Z. Now select all these rafters this way, make sure you have selected all the rafters, yes. Now assign to select beam, assign okay. Next select this one UNB 2.2, same way, go to here and select this way all the rafters, make sure everything all the raptors are selected. Yes, okay. Now for this two value should be for my columns, so go to here this view again, select this way all the columns, make sure you have all the columns selected. Okay, now assign yes. Next one, again go to here, select all, then assign yes. Okay, so after you have assigned all the parameter here, now go to here command, from here check code, add, and here is a takeoff. If you want to see the takeoff of the whole is still white, then click at takeoff, add. You can use multiple takeoff for say bracing separate and all the is still separate, you can use. I'm just showing you one. If you use more than one, then you have to add this couple time, then close. Here select this check code, I want to check for all members, so I have to click here this icon first, display whole structure, select this one, assign to views, assign yes, then takeoff I want to do for all, assign to views, assign yes. Okay, done. Save the model, and now go to here analyze tab again, then run analysis. After it has been completed, click here, go to post processing mode, done. Okay, and from here click beam, you need to check. Now you can check the value, go to here this top view, then select say this one and this one to check, right click. Okay, go to 3D view, now you check which size is working and which is not. So my raptor size at the gable is not working, I have to increase the size because this value is greater than 1, the value should be almost 1 or less than 1. So I have this raptor which is the value 1.23, so I have to increase the size of this one. This column is okay, this column is okay, and all other raptor main raptor is okay. I have to increase this raptor size, and I can also decrease this column size. You can see here this gable column is a little bit below 1, so I have to decrease this column size. I have to increase this raptor size, also increase this raptor size. Go to here modeling, general, from here I have okay, so I have these two column with the same size, I don't want to change this column. I will go for the next one. I have this raptor size, this should be changed. From here change this to say I want this is, say this is 8 and this one is 1010. Change yes. Okay, go below and now see this is my gable's column, double click. I want to reduce this one, I can use this is 1.5 and this is okay, change, close, and here is my gable raptor size, click here, this might be 300, 1.5, this may be 5, this may be 6. Oh sorry, I have to increase the size for this one, this is 3.5, say 8, this may be 10, change, close. Now go here again, analyze, run analysis, save, go to post processing mode, done. Okay, and beam, you need to check. Now you can see this column is okay and this column is almost okay, but I have to increase this size more. So this way you can increase size and then you can fix the adequate size for this raptor or all this column. Okay, now go to whole model and check here, my bracing is not working, so I have to increase the dia of the bracing. So if I want to increase the dia of the bracing, I have to go here, general, then go to below this one, double click on this. I have this is RD20, I can use say 24, change, yes, close. Same way, go again, analyze, run analysis, save, then go to post processing mode, done. Okay, beam, you need to check. Now you can see it is not working, so you have to increase this value more. This is a big project, that's why it is not working. And also the stat size is not working here, so you have to increase this stat size. So this way I hope you can fix your sizes. This is the procedure. And now see how you can check various forces here. Go to here post processing, and I'm just showing you. Go to your top value and select say this raptor, right click, new view. Okay, here, and first one is here deflection. you can check deflection from here, and you can see here a deflector shape which is in green color, and my current load combination is dead load plus live load. If I want to check value here, go to here results, view value, beam results, here displacement, maximum display resultant, annotate, close. Now you can see the value, and you have to check the allowable value as per your code requirement. This is the deflection, and if I want to check the sway of for this column, I can check here. This is the sway, you can see here 23.06 for this one. If I change the combination, it will be increased. This is now 59.85, and here the maximum is 94, and if I go dead load plus live load, you will see this is 204.67 maximum. So I have to check the allowable deflection as per my code, and I can check my deflection and side sway or lateral deflection from here, this icon. Just uncheck this one, click here MZ to check moment. You can see here the moment diagram. To show value here, go to here results, view value, similarly beam results, check these three under bending, annotate, yeah, okay, close. Now you can see, or by, and if you change from here this combination, you can see the value changing and the shape is also changing. And there is also another way of checking. If you double click on any member, then go to here design, still design. From here you can check the governing load combination here, which is the load combination 5 governing for this column. Going to a share bending, you can check bending, you can change here various combination, and you can see here value. You can also scroll to check value here in these three cells, and you can also check shear force same way. And to check deflection, you can also check deflection from here, selecting various combination from here. So this way you can check shear force, bending moment here, and you can also check shear force here. Uncheck this one and click here shear force, and from here select this one which is the FY shear force and FZ, and going to here results, view values, beam, this one, uncheck this, and shear force check these three, annotate, close. You can see your value, and by changing combination you can check value from here. And for axial force you have to go for from here, this is Fx. Now you can see axial force. To show axial force, similar, go to here results, view value, beam, and results, here the axial ends, annotate, okay, close. Now you can see the value. So this way you can check various forces. And the another thing is important to check the reaction. To check the reaction, I am showing you how to print the reaction. So you can print reaction by first click here this display whole structure, and just uncheck this fx. From here go to this V from Z, take this node cursor to select all the supports, right click, new view, okay, here hold down the shift key, then press K, then N, then S, K again. So just showing node and the node number. When in this way, click here this icon which is take a picture 1, okay, go to here file, from here report setup, and here is the available one is job information. If you want to print the job information, you can keep that here, otherwise you can just move from this right box to this left box. From here select picture 1, click this right arrow to move from left to right, then from here change output, and from here find reactions, this right arrow to show here, then go to here load cases. From here just select this first 4 cases and shift that from right box to left box. I want to check my reactions for these combinations only. Now click OK. Again go to here file, then print preview report. Now you can see your report preview. Here is the showing reactions for different node number. Now you can click here print, and if you have any Adobe Acrobat software installed, then it will show you here Adobe PDF, then properties. You can change here the paper size, then click OK. OK again, it will ask you to save this. You can save with any name. Okay, save. Now you can see this is the reaction, and this is the professional way of printing reaction. You can send this to anywhere for any purpose of foundation design. So this is the whole procedure of doing a complete structural design of a warehouse, which is a shed type of structure. And I hope after watching this video you can design this type of structure, if this is large or small, and regular or irregular shape. And using this same concept, I hope you can design this type of structure. And if you have any question, you can ask me in the comments and I will try to answer my best. I hope you have enjoyed this video. Thanks for watching this video, and hope to see you in any next video.